to our discussion of double and half angle formulas, and in this video we're going to actually use some of those formulas to verify some trig identities. Let's see what that looks like. All right, so we have spent some time verifying identities, and what we're going to end up doing is actually we're going to use those double angle and half angle identities to verify. All right, so we have two examples here. In both of these examples, you'll notice there is a trig expression that involves a double angle. Okay, so you see that here and here. Okay, so let's focus our attention on the very first identity. All right, we're going to stay with the mentality that we want to only focus our attention on one side of the equation at a time. Which side of the equation do you think is a little more complicated? Now, if I'm looking at this, I've got something squared over here and then just a couple of different terms over here. And so I would kind of think that this left-hand side is a little more complicated, and it gives me an idea of what I might want to do. Since I know that I'm trying to square the expression, the whole expression, sine of x plus the cosine of x, I'm going to think about, well, what would that look like if I squared it, right? I would have sine of x plus cosine of x times sine of x plus cosine of x. And so I would distribute that all out, and I would end up with sine squared of x plus 2 sine x cosine x plus cosine squared of x. And that is going to stay equal to the right-hand side. We're going to leave that right-hand side alone. Now, if I'm looking at that left-hand side, man, I see a couple of things that are squared, which always means I want to think about Pythagorean identities. Let's go ahead and just put those two things together and then think about what it looks like. Let's just switch the order of these two things. Sine squared of x plus cosine squared of x plus 2 sine x cosine x, and set that equal to 1 plus cosine of 2x. Okay. Well, do you remember what this is equal to? Sine squared of x plus cosine squared of x? Hopefully you remember that that is the big Pythagorean identity, and that's just 1. Now, 2 sine x cosine x, that's your double angle identity. And so I can change that into sine of 2x, and then we'd be finished. I've got the left side equaling the right side, and I'm good to go. Woohoo! Okay, let's look at the second one. Now, again, I'm thinking which of the two sides of the equation looks a little more challenging, which is a little more complicated. And in this case, I would go with the fraction. I would look at that fraction and think to myself, cosine of 2x over cosine squared of x. What is the cosine of 2x? And remember, we have 3 different options. Okay, so I'm going to start by thinking about this with my favorite of the 3, cosine squared of x minus sine squared of x. So let's just rewrite the right-hand side so it looks like that. Oh, okay. When I see it in this way, I'm thinking, let's split this thing up. Let's split it into 2 fractions with the same denominator. Okay, so the right-hand side now looks like this. Okay, well now I think I have exactly what I'm looking for, right? Because cosine squared of x over cosine squared of x, that's 1. And sine squared of x divided by cosine squared of x is tangent squared of x. And so when I rewrite it in that way, I'm all finished. And that one's done. Way to go. Okay, in the next video, we're going to talk about actually using some things in the plane with double angle formulas. I'll see you then.